Hello and welcome to this video on completing the square. I'm going to teach you how to pretty much complete the square for any quadratic you're going to come up against at GCSE level. And we do this because we want to either solve a quadratic using this method or because we want to find the minimum point of a quadratic graph, right? But in this video I'm just going to focus on teaching you how to complete the square. So let's take a look at this example. We've got x squared plus 4x plus 10 and we want to write it in the form x plus a all squared plus b. Now this form here is what we call the completed square form. So what we need to do is turn this quadratic into something that's equal to and looks like that. And when we've done that, we've completed the square. So it's quite easy to do, okay? So here's how we're going to do it. We start off by focusing on the first two terms, okay? So the x squared plus 4. And what we do is we're going to write a bracket and we say x, and then we look at the coefficient of the x in the original quadratic equation, which in this case is plus 4. And we half it, we divide it by 2. So that becomes, rather than plus 4, we write plus 2, okay? And then we square that. Now if I expand that, let's see what we get. We've got x plus 2 multiplied by x plus 2. And if we expand it, we get x multiplied by x, which is x squared, x multiplied by 2, which is 2x, 2 multiplied by x, which is 2x, and 2 multiplied by 2, which is plus 4. Now if I simplify this and collect like terms, we find that x plus 2 squared, okay, is equal to x squared plus 4x plus 4. And we'll notice if we look at what happens when we expand it, the first two terms are the exact same as the original quadratic. And you can kind of see it's starting to look a bit like the completed square form. The only difference is here we have a plus 4, and on the original we've got plus 10. So to turn that plus 4 into a plus 10, I could just add 6, couldn't I? So let's add 6 to what we've got. And when we do that, we find that we get the original quadratic equation, and also that we've got it in this special form, which is the completed square form. So in this case, a would be equal to 2 and b would be equal to 6. Pretty easy, right? So let's take a look at another example. Exactly the same thing. Look at the first two terms. Okay. Now we can write x plus, well, half of the coefficient of x, so plus 3, and square that. Now I'm just going to expand it, but if you want to do it yourself and check that how this works, you can. But we're going to get x squared plus 6x plus 9, and you'll notice the first two terms are the exact same. The only difference is these last constant terms. So in our one we've got plus 9, but we want it to read plus 7. And we can do that by subtracting 2, okay? So we can get x plus 3 squared, subtract 2, and that equals the original quadratic. And we've completed the square, okay? So this is our completed square form, where a is equal to 3 and b is equal to negative 2, if you want to compare it to this. Nice and easy. Now sometimes you'll get a slightly trickier example, okay, which looks something like this. X squared plus 3x minus 7. Now we continue with it the same way, and the reason it's slightly tricky, okay, is because if we look, when I half the coefficient of x, rather than getting a whole number, I'll get 3 divided by 2, which is 1.5. So we get a decimal, which is slightly trickier to work with, okay? Now, rather than writing 1.5, I'm going to leave it as 3 over 2. And the reason I'm going to do that is because, one, if you do A-level maths, you'll usually just work with fractions because they're easier to use. And also, I just find them easier to use myself. So, x plus 3 over 2 all squared. So that's x plus 3 over 2 multiplied by x plus 3 over 2. So let's expand it and we get x multiplied by x, which is x squared. X multiplied by 3 over 2, which is 3 over 2x. 3 over 2 multiplied by x, which is 3 over 2x. And 3 over 2 multiplied by 3 over 2, which is 9 over 4. Again, I'm leaving it as fractions. Now if we collect like terms and we simplify this, so x plus 3 over 2 all squared is equal to x squared plus 3x plus 9 over 4. That's what we get, right? Once again, the first two terms are the same, but you'll notice we've got plus 9 over 4, but we want it to read negative 7. So we need to add something or subtract something to make this plus 9 over 4 equal negative 7. And the way I'm going to do that is say, well, if I subtracted 9 over 4, that would take this to x squared plus 3x, so it's taken the number down to 0. And from there, I just need to subtract 7 to get to negative 7. Now, to save me time, I'm just going to work this out on my calculator. So 9 over 4, or negative 9 over 4, subtract 7. That takes me to negative 37 over 4. So I need to subtract negative 37 over 4, which if you want it as a decimal is negative 9.25, from what I've got to get me to the original. So I'm going to write x plus 3 over 2 all squared, subtract 37 over 4. And that equals the original quadratic equation, where a is equal to 3 over 2 and b is equal to negative 37 over 4. So even with trickier ones like this where we've got fractions, it's still not too tricky, okay? Now this is the final example that I'm going to show you, and this is like the toughest ones that you might come across, which is where the coefficient of x squared isn't 1. So the way we can do this, right, if we've got a coefficient of x squared being bigger than 1, okay, is we need to make it 1, because if you look at all these examples, to put it into this form here, the coefficient of x squared was 1. So to turn this 2 into a 1, I could just pull it out as a factor, okay? And so we're still only going to be interested in these first two terms, but I'm going to factorize out the 2. So factorizing out 2 leaves me with x squared, subtract 6x, okay? And again, I'm just focusing on the first two terms in this equation for now. Now the coefficient of my x squared is 1, I can just put it into my completed square form, right? Kind of, right? I can do the process. So I'm going to leave the 2 out the front, okay? I'm going to use this square bracket because I'm going to use another bracket. And I'm going to do x and then half the coefficient of whatever x is, so subtract 3 squared, okay? Now let's see what happens if I expand that. Well, I'll write it over here. X minus 3 all squared gives me x squared, subtract 6x plus 9, okay? So let me write that. So I've got two lots of, let me write it down, x squared minus 6x plus 9. Now let's see what happens if I expand these brackets. So if I expand it, I'm doing 2 times x squared, 2 times negative 6x, and 2 times 9. So let's work that out. We're going to get 2x squared minus 12x plus 18. Now let's take a look at the first two terms. You'll notice they're the same as the original. The only difference is, again, this constant term is plus 18, but I want it to be plus 23. So to make it plus 23, I need to add 5. And I need to add 5 to this, okay? So I'm going to have 2 times x minus 3 all squared plus 5. And if I expand all that, I'll get the original quadratic equation. And you'll also notice that this is now in my completed square form, where a is equal to 2, b is equal to negative 3, and c is equal to 5. And that's probably one of the trickiest examples that you would come up against at GCSE. So if you can do that, you're pretty much laughing. So thanks for watching. Subscribe to my channel and go on my channel for more tutorials, or go over and follow my TikTok for worked exam questions. Thanks for watching.